Hello everyone. So let's solve question number 3. If an integer n is written as a product of prime numbers, this product can be used to determine the number of positive factors of n. And for example, it is given that 28 is equal to 2 to the power 2 into 7 to the power 1. So how many positive factors of 28 are there? So the example is given. How many ways like we can write? So the thing which we have to consider, just look at the prime numbers, just look at the prime factors and look at their power, look at their exponents. Like this is 2 to the power 2. So if you look at this place, the power of 2 has how many choices? Like you can write 2 to the power 2 or 2 to the power 1 or 2 to the power 0. All will be the factor of 28. So because here 2 is the power, so we have three choices. And if you look at the second prime factor, which is 7, so this is 7 to the power 1. So we have two choices. Either we can write 7 to the power 1 or 7 to the power 0. These both number will also be the factor of 28. So because it has two prime factors and one has three choices and the other has two choices, so we can say 3 times 2, 28 has six positive factors, which we can verify the listing the factors like 1, 2, 3, 4, 5, 6. Okay, now the question is how many positive factors 675 has have. Okay, so 675. So if you prime factorize 675, this will be 3 to the power 3 times 5 to the power 2. So now 675 has two prime factors, and prime factor 3 has power of 3 and it has four choices: 3, 2, 1, 0. And factor 5, this is 5 to the power of 2, so it has three choices: 2, 1, and 0. Three choices: 2, 1, and 0. So 4 times 3, this is 12. So 675 has 12 factors, 12 positive factors, right? Okay. Question number 2. A positive integer n has positive factors 9, 11, 15, and 25 exactly, which is 4 and 14 other positive factors. So the number has already four, these four factors are given and 14 other factors. So n has 4 plus 14, it has 18 factors. Okay, so the number which has all these factors should be exactly divisible by all these numbers. So the smallest number which is exactly divisible by all these four numbers 9, 11, 15, and 25 will be the lowest common multiple, will be the LCM of these numbers. Like so 9 is 3 to the power of 2, 11 is 11 to the power 1, 15 is 3 to the power of 1, 5 to the power of 1, and 25. 25 is 5 to the power of 2. So n can be, this is, so we'll take the highest power of each prime factor. So it can be 3 to the power of 2, 5 to the power of 2, and 11 to the power of 1. So if you look at n and its prime factors, how many factors n can have? So number of factors. So as I told you, look at the power of the prime number. This is 3 to the power of 2. So it has three choices, and this is also 5 to the power of 2. So since the power of 2, power can be 2, 1, and 0. It also has three choices, and 11 to the power 1 has two choices. So you can see this, there are 18 factors. So obviously this has 18 factors, so this should be the number, and n is equal to, this is 9 times This is 9 times 25 times 11. Okay, so 9 times 25 times 11, this is 2475. 2475. So this is the value of n. All right. Question number C. Determine the number of positive integers less than 500 that have a positive factor of 2 and 9 exactly, and exactly 10 positive factors. So apart from 2 and 9, the number has 10 positive factors. So total number of factors will be 2 plus 10. So it has 12 positive factors, right? Okay. Um, so 2 is obviously, that's 2 to the power 1, and 9 is 3 to the power of 2. So what if it has only two factors? Okay. So we assume that the number is m and it has only two positive factors. So it can have two, it can have three factors, it can have four factors, and we'll consider each case. So first consider that the number m has two factors, 2 and 3, and the power is also unknown, so we can write 2 to the power of a and 3 to the power of b, right? So an a obviously should be equal to or greater than 1, and b should be equal to or greater than 2, right? So if 2 to the power of a, it means how many choices the first factor has. So we can say a plus 1. So yes, okay. So like the factor when 3 to the power 2 was written, so the number of choices we have is 3. So a plus 1. And similarly here we can write b plus 1, and the product of these two possibilities should be equal to 12. So solving this, we can conclude that, so we can say that a plus 1, see if a plus 1, a is greater than 1, we have this, so we can add 1 to both sides, so we can have a plus 1 greater than or equal to 2, and b plus 1 greater than or equal to, so we can say b 2 plus 1, so b plus 1 is greater than or equal to 3, right? So now we have how many conditions we have how many choices. See, if what can happen, let's say a plus 1 is equal to 2. In that case, because their product is 12, so b plus 1 will be equal to 6. It means a is 1, and that gives you, so this is first case, that gives you a is 1 and b is 5. All right. So let's say, what if a plus 1 is like greater than 2? That's 3, because it's greater than 2. So in that case, b plus 1 will be, because the product is 12, it will be 4. In that case, a will be 2 and b will be 3. It is also possible that a plus 1 is equal to 4. In that case, b plus 1 will be 3, and so a will be 3 and b will be 2, right? So this is 3 and 2. Okay, so these are the possibilities. So we can say m is equal to, in the first case, 2 to the power 1 times 3 to the power of 5, and that gives you 486. Or we can say m is equal to 2 to the power of 2 and 3 to the power of 3. That's 27 times 4, that's That's 108. And or we can say 2 to the power of 3 times 3 to the power of 2, that's 8 times 9, which is 72. So here, if the m has only two factors, so less than 500 three numbers are possible. What if m has exactly three factors? So if m has three factors, so this is 2 to the power of a, 3 to the power of b, and there is another number which is p, let's say, which, and it has power of c. P is a prime number. See, it is clear that a is greater than or equal to 1, b is greater than or equal to 2, that we already know. So let's say if a is 1, which is already given, right? So b is, let's say b is 2 in that case, because 3 plus 2, that's 6. So c can be 1. So c can be 1 in that case. Okay. So we can write, because c is 1, so we can write m is equal to, replacing a, b, and c, we can write m is 18p. And this number 18p is less than 500. So we can write p is greater than, or yes, smaller than 500 over 18, which gives you p is smaller than or equal to 27. 27. It means all the prime numbers except 2 and 3, which is smaller than 27. So possible, so what are the possible numbers? 5, 7, 11, 13, 17, 19, 23. Okay. So that's 1, 2, 3, 4, 5, 6, 7. So there are 7 uh, prime numbers which can replace p if it has exactly two factors, right? So and if it has exactly four factors, so if m has four factors, so m will be 2 to the power of a, 3 to the power of b, p to the power of c, and q to the power of d. In that case, see, if minimum, in the minimum case, a is 1, b is 2, and c is 1, then there is no, and obviously d is 1. So the number of possibilities will be 2 times 3 times 2 times 2, which is 24, and which is not possible. So the question is number of positive integers less than 500. So how many possibilities? In the first case there are 3 possibilities, and in the second case we have 7 possibilities. So 3 plus 7, so 10 possible numbers are there which is less than 500, and also it has a factor of 2 and 9.